The moon has always been an object of fascination for humanity. Hanging in the night sky, this celestial body has inspired countless myths, legends, and scientific inquiries. It is the brightest object in the night sky, and although it seems close to us, the moon is actually about 384,400 kilometers, 238,855 miles, away from Earth. Over the course of human history, the moon has been a source of both wonder and mystery. From the earliest observations by ancient civilizations to the modern-day lunar missions, humanity's relationship with the moon has evolved, bringing us closer to understanding its significance in both cultural and scientific realms. The moon is Earth's only natural satellite, and it plays a vital role in many aspects of our planet. It controls the tides, helps regulate Earth's climate, and influences the behavior of various species on Earth, particularly those that are nocturnal. Beyond its physical influence, the moon has captured the imagination of humans for millennia, appearing in ancient mythology, literature, and art. Its phases, waxing and waning, full and new, have been used by various cultures to measure time, guide agricultural activities, and predict natural phenomena. From a scientific perspective, the moon is a barren, airless world. Its surface is covered in a thick layer of dust and debris, known as regolith, formed by the impact of countless meteoroids over billions of years. The craters that mark its surface are reminders of its violent history, recording the impact events that have shaped its landscape. Despite its desolate appearance, the moon is a treasure trove of information about the early solar system. Since the moon lacks an atmosphere to erode or weather its surface, its craters and features remain relatively unchanged, providing scientists with a pristine record of the solar system's formation. The moon's origins can be traced back to a cataclysmic event billions of years ago. The prevailing theory is that a Mars-sized body, known as Theia, collided with the early Earth. The impact was so powerful that debris from both Theia and Earth was ejected into space. Over time, this debris coalesced, forming the moon. This theory, known as the giant impact hypothesis, explains many of the moon's characteristics, including its composition, which is remarkably similar to that of Earth's mantle. One of the most significant events in human history took place on July 20, 1969, when astronauts Neil Armstrong and Buzz Aldrin set foot on the lunar surface during NASA's Apollo 11 mission. This moment marked the first time humans had walked on another celestial body. Armstrong's famous words, "That's one small step for man, one giant leap for mankind," have since become synonymous with human achievement and exploration. The Apollo missions not only demonstrated humanity's ability to reach the moon, but they also provided invaluable scientific data, including rock samples and measurements that have enhanced our understanding of the moon's geology. The success of the Apollo mission sparked further interest in lunar exploration. While the last crewed mission to the moon was Apollo 17 in 1972, robotic missions have continued to study the moon. Various countries, including the United States, Russia, China, and India, have sent spacecraft to explore the moon's surface, study its resources, and prepare for future crewed missions. The discovery of water ice at the moon's poles has raised the possibility of establishing a permanent lunar base, which could serve as a stepping stone for deeper space exploration, including missions to Mars. In addition to scientific exploration, the moon has been a subject of artistic inspiration for centuries. In literature, it has been used as a symbol of change, mystery, and emotion. Poets have written about the moon's beauty and its role as a silent observer of human affairs. In visual art, the moon has been depicted in various forms, from the glowing full moon illuminating a landscape to the crescent moon hanging delicately in the night sky. Music has also been inspired by the moon, with countless songs and compositions celebrating its allure and mystery. The phases of the moon have been particularly significant in human culture. The lunar cycle, which lasts about 29.5 days, is divided into several phases: new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and waning crescent. These phases are caused by the relative positions of the Earth, Moon, and Sunday. As the Moon orbits Earth, the portion of its surface that is illuminated by the Sun changes, creating the appearance of different phases. The full moon, when the entire face of the moon is illuminated, has been a source of fascination and even fear in various cultures. Some believe that the full moon affects human behavior, leading to myths of werewolves and other supernatural phenomena. In modern times, the moon continues to captivate scientists and dreamers alike. With advancements in technology, we are on the cusp of a new era of lunar exploration. NASA's Artemis program aims to return humans to the moon by the mid-2020s, with the goal of establishing a sustainable presence on the lunar surface. This ambitious endeavor seeks to not only explore the moon but also to use it as a base for missions to Mars and beyond. The moon, once a distant and mysterious object, is now within our reach, and its exploration will continue to push the boundaries of human knowledge and achievement. However, the moon is not just a scientific object or a cultural symbol. It also holds personal significance for many people. For centuries, humans have gazed up at the moon, pondering its mysteries and feeling a sense of connection to something larger than themselves. Whether it is through the lens of a telescope, a work of art, or a simple walk under the night sky, the moon continues to inspire awe and wonder. As we look to the future, the moon remains a symbol of both our curiosity and our ability to dream. It represents the challenges we face in exploration and the rewards that come with pushing the limits of human endeavor. The moon reminds us that even in the vastness of space, there are places we can go, mysteries we can uncover, and stories we can tell. It is not just a rock in the sky, it is a beacon of possibility, guiding us toward the next great leap in human exploration. The moon's allure stretches far beyond scientific curiosity. For millennia, it has shaped the very way we see the world and interact with it, influencing everything from ancient calendars to human behaviors. Early humans likely marveled at its cyclical appearance, its predictability providing a sense of rhythm to life. Civilizations used the lunar cycle to structure their agricultural practices, planning harvests and plantings based on the phases of the moon. In fact, the word month itself is derived from the word moon, a reflection of how intertwined lunar observation was with the development of early timekeeping systems. The moon's role in the regulation of tides, as mentioned earlier, has been critical in shaping ecosystems and human settlements. The gravitational pull exerted by the moon causes the oceans to bulge, creating high and low tides. This rhythmic rising and falling of sea levels influences coastal environments, providing the conditions necessary for a variety of marine life to thrive. Estuaries, where rivers meet the sea, are particularly affected by tidal movements, as they depend on the balance between fresh and salt water that tides provide. The intertidal zone, the area of the coast that is underwater at high tide and exposed at low tide, is home to diverse species adapted to this constantly changing environment. Humans have long relied on the predictability of tides for fishing, transportation, and even warfare. For instance, naval strategies throughout history have taken tidal movements into account to gain an advantage over opponents. Beyond Earth, the moon's gravitational influence also plays a stabilizing role for our planet. One of its most critical contributions is the stabilization of Earth's axial tilt. This tilt, which is responsible for the changing of the seasons, could fluctuate wildly if it weren't for the moon. Without the moon's stabilizing presence, Earth's climate would be far less predictable, with extreme shifts in temperature and potentially catastrophic effects on the development of life. The moon acts almost like a cosmic anchor, keeping Earth's axial tilt relatively constant over long periods of time, which has allowed for the stable climatic conditions necessary for life to evolve and flourish. The moon's composition and geology offer scientists clues not only about its own formation but also about Earth's early history. When the Apollo astronauts brought back lunar samples, these rocks revealed the moon's surface is primarily made up of basalt, a volcanic rock, and an orthosite, a rock formed in the moon's early crust. The moon's interior is differentiated, meaning it has a core, mantle, and crust similar to Earth, though its core is much smaller in proportion to its overall size. One of the moon's most fascinating features is the presence of large, flat plains called Maria, Latin for seas, which are vast, solidified lava flows that were created by volcanic activity billions of years ago. These dark patches cover much of the moon's near side, giving it its characteristic appearance, while the far side of the moon, which we never see from Earth due to the phenomenon of tidal locking, is heavily cratered and lacks these large lava plains. Tidal locking itself is a fascinating aspect of the Earth-Moon relationship. The moon rotates on its axis, but the time it takes to complete one rotation is the same as the time it takes to orbit Earth. As a result, the same side of the moon always faces Earth. This synchronization, known as synchronous rotation, means that humans have only ever seen one hemisphere of the moon with the naked eye. It wasn't until the advent of space exploration that we finally saw the far side of the moon, which was first photographed by the Soviet spacecraft Luna 3 in 1959. The far side, often incorrectly called the dark side, is not actually perpetually dark. It receives just as much sunlight as the near side, but because of the moon's tidal locking, it remains hidden from Earth. The moon's far side continues to intrigue scientists, and it is considered one of the most promising locations for future exploration. Unlike the near side, which has been extensively studied, the far side remains largely unexplored. China's Chang'e 4 mission made history in 2019 when it became the first spacecraft to successfully land on the far side of the moon. The mission's rover Yutu-2 has been exploring the region, providing unprecedented data about the far side's geology and surface composition. The far side of the moon is also of interest to astronomers, as it is shielded from the radio noise generated by human activities on Earth, making it an ideal location for the establishment of radio telescopes that could peer deep into the universe without interference. Lunar exploration, particularly the return of humans to the moon, represents not only scientific achievement but also humanity's innate desire to push boundaries and explore the unknown. The Artemis program, named after the twin sister of Apollo in Greek mythology, aims to return humans to the lunar surface and establish a sustainable presence by building a lunar base. Such a base could serve as a hub for scientific research, resource extraction, and even tourism. One of the key objectives of the Artemis program is to mine water ice from the moon's poles, which could be used to produce oxygen and hydrogen for fuel, enabling long-term human missions on the moon and beyond. Establishing a permanent presence on the moon would also pave the way for human missions to Mars and other parts of the solar system. The moon could act as a way station, a place where spacecraft could refuel, resupply, and launch more easily due to the lower gravity compared to Earth. This concept of using the moon as a stepping stone to the rest of the solar system has reignited humanity's fascination with space exploration, inspiring new generations of scientists, engineers, and dreamers to imagine what the future holds. In addition to technological and scientific advancements, the prospect of human colonization of the moon raises philosophical and ethical questions. What would it mean to live on another celestial body? How would humans adapt to life in an environment so different from Earth? What impact would such a presence have on the moon's natural environment? These are questions that humanity will need to address as we move closer to realizing the dream of lunar colonization. For all of its scientific significance, the moon also holds a special place in the human psyche as a symbol of mystery, transformation, and aspiration. From ancient rituals performed under its light to the modern-day quest to colonize its surface, the moon has always represented the interplay between the known and the unknown, the familiar and the uncharted. Its pale glow reminds us of the vastness of the cosmos, the limits of human knowledge, and the endless possibilities that await us in the stars. As we prepare to once again set foot on the lunar surface, the moon will continue to be a source of inspiration. Its influence on Earth, its role in shaping human culture, and its potential as a gateway to the cosmos ensure that it will remain a central figure in the story of human exploration for generations to come. The moon, in all its silent majesty, beckons us to explore, to discover, and to dream. It is not just a destination, it is a symbol of what we, as a species, are capable of achieving. The moon stands as a testament to our past and a beacon for our future, lighting the way for the next chapter in the ongoing saga of human curiosity and exploration. As we stand on the brink of a new era of space exploration, the moon continues to be a vital focal point for our ambitions and aspirations. The Artemis program, with its goal of not just visiting the moon but establishing a sustainable human presence there, represents the culmination of decades of dreams, planning, and technological progress. This initiative, led by NASA but involving international partnerships with agencies like the European Space Agency, ESA, will bring humans back to the moon for the first time in over 50 years, marking a new chapter in our relationship with our celestial neighbor. However, establishing a permanent presence on the moon comes with significant challenges. The moon's environment is inhospitable to life as we know it, lacking an atmosphere to provide protection from the sun's harmful radiation and meteoroid impacts. Temperatures on the lunar surface vary wildly, from extreme cold during the lunar night to scorching heat during the lunar day. The lack of air, water, and food on the moon means that any long-term habitation would require the transport and production of essential resources, or the development of advanced technologies that allow humans to live off the land, so to speak. This is where the discovery of water ice in the moon's polar regions becomes critical. Lunar water, particularly in the form of ice trapped in permanently shadowed craters, has the potential to be one of the most valuable resources in the solar system. Not only could this water be purified for drinking and other uses, but it could also be split into hydrogen and oxygen, two components that could be used for rocket fuel. This would allow future missions to refuel on the moon, making deep space exploration more feasible and reducing the need for costly launches from Earth's surface. The ability to utilize lunar resources, known as in situ resource utilization, ISRU, is one of the primary goals of the Artemis program, as it will be key to making sustained lunar exploration a reality. In addition to water, the moon is rich in other resources, including minerals and metals such as titanium, iron, and aluminum. These materials could be used to build infrastructure on the moon itself, from habitats and research stations to landing pads and communication towers. Lunar regolith, the dust that covers the moon's surface, could even be used to construct buildings through 3D printing technology, a process that has been tested on Earth and is seen as a viable method for building structures on other planets. By harnessing the moon's resources, humans could reduce their reliance on supply missions from Earth, making lunar colonies more self-sufficient and sustainable. Living on the moon, however, would require more than just overcoming physical challenges. It would also demand significant psychological and social adaptations. Human beings are deeply connected to Earth's environment, from the natural rhythms of the day-night cycle to the availability of fresh air, water, and familiar foods. On the moon, astronauts would have to live in enclosed, artificial environments for extended periods, which could lead to feelings of isolation, claustrophobia, or even depression. The lack of direct communication with loved ones, the limited range of activities, and the monotony of the lunar landscape could also contribute to mental health challenges. To address these concerns, space agencies are conducting extensive research into the psychological and physiological effects of long-term space habitation. Studies aboard the International Space Station, ISS, have provided valuable insights into how humans adapt to living in space for months or even years at a time. These studies have revealed the importance of maintaining regular communication with Earth, providing astronauts with varied and meaningful tasks, and ensuring they have access to recreational activities and personal time. On the moon, these principles will need to be applied in new and innovative ways, particularly as lunar missions will likely be more isolated and challenging than those aboard the ISS. Despite the challenges, the potential benefits of lunar exploration and colonization are enormous. The moon could serve as a testing ground for technologies that will eventually be used on Mars and other planets. By building habitats, growing food, and extracting resources on the moon, humans can gain the experience and expertise needed to survive and thrive in even more hostile environments. The moon's proximity to Earth also makes it an ideal location for astronomical observatories, free from the interference of Earth's atmosphere. Telescopes on the far side of the moon, shielded from Earth's radio noise, could observe the universe in unprecedented detail, potentially leading to new discoveries about the origins of the cosmos. In addition to scientific advancements, a permanent human presence on the moon could have significant cultural and philosophical implications. The act of living on another world, even one as close as the moon, would fundamentally change our perspective on what it means to be human. It would force us to confront questions about our place in the universe, our relationship with the natural world, and our responsibilities to one another as a species. The experience of seeing Earth from the lunar surface, small, fragile, and suspended in the blackness of space, could inspire a deeper sense of unity and stewardship for our home planet. The moon has always been a symbol of aspiration, mystery, and the unknown. Throughout human history, it has been a constant companion, its phases marking the passage of time and its presence lighting our darkest nights. Now, as we prepare to return to the moon and stay there, we are on the cusp of turning those ancient dreams into reality. The moon represents both our past and our future, a place where we can explore the mysteries of the universe while also reflecting on what it means to be human. The next few decades will likely see dramatic changes in how we view and interact with the moon. As lunar exploration moves from short-term missions to long-term habitation, humanity's relationship with the moon will evolve in ways we can only begin to imagine. The moon will no longer be just a distant object in the sky. It will become a new frontier, a place where humans live, work, and dream. It will be a place where we push the boundaries of science, technology, and human endurance, all while remaining tethered to the planet that has been our home for millions of years. The moon is more than just a rock in space. It is a symbol of our endless curiosity, our drive to explore the unknown, and our ability to achieve the seemingly impossible. As we continue to reach for the moon, we are also reaching for something deeper within ourselves, the desire to understand our place in the cosmos and to leave our mark on the universe. The moon, with all its craters, mountains, and mysteries, beckons us forward, inviting us to explore, to discover, and to dream. It is a journey that has only just begun, and the possibilities are as boundless as the stars themselves. The journey to the moon is not just a scientific endeavor, but one that taps into the very core of human imagination, ambition, and philosophy. When humans first landed on the moon in 1969 with the Apollo 11 mission, the achievement was not merely a victory in the space race, but a moment that transcended borders, politics, and individual nations. It was a milestone in human history that embodied the limitless possibilities of what we can achieve as a species. The image of Neil Armstrong descending the ladder and setting foot on the lunar surface, accompanied by his iconic words, "That's one small step for man, one giant leap for mankind," remains etched in the collective memory of humanity. It was not just about a single man stepping onto the moon. It was the culmination of centuries of dreaming, exploration, and human progress. The Apollo program was a monumental achievement, but it also marked the end of an era in some ways. After Apollo 17 in 1972, humans have not returned to the lunar surface. The reasons for this are manifold. The costs of space exploration, political shifts, and the growing focus on other areas of research and development meant that further lunar missions took a backseat for several decades. However, the vision of returning to the moon never fully disappeared. It continued to inspire generations of scientists, engineers, and dreamers who understood the significance of the moon in not just scientific terms, but also in terms of what it represents for humanity's future in space. Fast forward to today, and we are once again at the cusp of returning to the moon with renewed vigor. The Artemis program, alongside private space companies like SpaceX, Blue Origin, and others, represents a new chapter in lunar exploration, one with the ambition not just to visit the moon but to stay. The goal is not only to land astronauts on the lunar surface but to establish a permanent presence there, something that was unimaginable during the Apollo era. But what does it mean to have a permanent presence on the moon? What are the philosophical, ethical, and societal implications of becoming a multiplanetary species? The idea of colonizing the moon has long been a subject of science fiction, but it is now becoming a serious scientific and engineering challenge. Building habitats on the lunar surface would require overcoming numerous technical hurdles, from providing sustainable sources of water and oxygen to protecting inhabitants from cosmic radiation. While the Apollo astronauts stayed on the moon for only a few days at a time, the astronauts of the Artemis program and beyond would need to stay for weeks, months, or even years. This raises fundamental questions about how humans would adapt to living in an environment so radically different from Earth. One of the key challenges is the moon's lack of atmosphere. On Earth, our atmosphere protects us from harmful solar and cosmic radiation, while also providing the air we need to breathe. On the moon, there is no such protection. Any long-term habitat on the moon would need to be designed to shield its occupants from these dangers, either by building structures underground or by using advanced materials that can block radiation. Some proposals even suggest using the lunar regolith, the layer of dust and rock that covers the moon's surface, as a natural barrier, by piling it on top of habitats to create an insulating layer. Another major challenge is the moon's low gravity. The moon has only about 1/6 of Earth's gravity, and while this might seem like a fun novelty at first, as the Apollo astronauts demonstrated with their bounding leaps across the lunar surface, it presents significant long-term health concerns. Humans evolved in Earth's gravity, and prolonged exposure to low-gravity environments can lead to muscle atrophy, bone loss, and other physiological issues. Astronauts on the International Space Station, ISS, already experience these effects in microgravity, and while exercise regimes and other countermeasures can mitigate some of the damage, we still don't fully understand the long-term effects of living in a low-gravity environment like the moon. The psychological effects of living on the moon are also an area of concern. While the ISS is relatively close to Earth, with constant communication and regular resupply missions, the moon is much farther away. Astronauts on the moon would be more isolated from Earth, both physically and mentally. The isolation, combined with the harshness of the lunar environment and the confined spaces of lunar habitats, could lead to feelings of loneliness, depression, and anxiety. Scientists and engineers are working to design habitats that are not only functional but also comfortable and psychologically supportive, with spaces for recreation, communication with Earth, and even opportunities for virtual reality experiences to simulate the feeling of being back on Earth. In addition to these practical concerns, there are also broader ethical questions about the colonization of the moon. Who owns the moon? According to international agreements like the Outer Space Treaty of 1967, no nation can claim sovereignty over the moon or other celestial bodies. The moon is considered the province of all mankind, a place that belongs to everyone and no one. But as space exploration becomes increasingly commercialized, with private companies developing plans for mining the moon's resources, questions arise about how these activities should be regulated. Should private companies be allowed to mine the moon for profit? How should the benefits of lunar resources be shared? And what responsibility do we have to preserve the moon's environment for future generations? While these challenges are significant, the potential rewards of establishing a permanent presence on the moon are equally profound. The moon could serve as a stepping stone for further exploration of the solar system, including missions to Mars and beyond. The experience gained from living and working on the moon could help humanity develop the technologies and expertise needed to survive in even more hostile environments, such as the surface of Mars or the icy moons of Jupiter and Saturn. In addition to its role as a platform for space exploration, the moon could also provide new opportunities for scientific research. Lunar observatories, free from the interference of Earth's atmosphere and radio noise, could make groundbreaking discoveries about the universe. The moon's surface, with its lack of erosion and tectonic activity, preserves a record of the early solar system, offering scientists a unique opportunity to study the history of our cosmic neighborhood. Furthermore, the moon's resources, such as water ice, could be used to support not only lunar colonies but also missions to deeper parts of space, reducing the need for resupply missions from Earth. There is also the potential for economic benefits from lunar exploration. The moon is rich in certain rare minerals, such as helium-3, which could be used as fuel for future nuclear fusion reactors. While the technology for fusion power is still in development, The prospect of mining the moon for such valuable resources has captured the imagination of entrepreneurs and governments alike. The moon could become the hub of a new space economy, with industries ranging from mining and manufacturing to tourism and research. The idea of space tourism is particularly intriguing. While the first space tourists have already flown aboard suborbital flights and the International Space Station, the prospect of visiting the moon offers an entirely new level of adventure. Imagine hotels on the lunar surface, where visitors could experience the thrill of low-gravity environments, walk in the footsteps of the Apollo astronauts, and gaze at the distant Earth from the lunar horizon. While such a vision may seem far-fetched now, it is not beyond the realm of possibility in the coming decades. In many ways, the moon represents a new frontier for human exploration and development, one that will challenge us to rethink our place in the universe and our responsibilities as stewards of the cosmos. The dream of living on the moon is no longer confined to the pages of science fiction. It is becoming a reality, one step at a time. The Artemis program and the efforts of private space companies are paving the way for a future in which humans are no longer confined to Earth but are part of a larger, multiplanetary civilization. But even as we reach for the stars, the moon will always hold a special place in our hearts. It is the celestial body that has been with us since the beginning of human history, inspiring myths, guiding explorers, and serving as a symbol of hope and wonder. The moon's pale light has illuminated our nights for millennia, and now, as we prepare to return to its surface, it beckons us to explore, to discover, and to dream. The journey to the moon is not just about reaching a new destination. It is about understanding who we are as a species and what we are capable of achieving. It is about pushing the boundaries of human knowledge and exploration, about daring to go where no one has gone before. The moon is both a challenge and an opportunity, a place where we can test the limits of our technology, our ingenuity, and our imagination. And as we set our sights on this distant world, we are reminded that the sky is not the limit, it is just the beginning. The journey to the moon is not just a technological challenge, but an endeavor that will fundamentally alter how we perceive ourselves and our place in the universe. As we continue to push toward establishing a long-term presence on the lunar surface, the social, economic, and philosophical implications of such an achievement grow ever more significant. One of the most profound aspects of human expansion beyond Earth is the inevitable redefinition of what it means to be human. Our species has been rooted in a terrestrial existence for all of history. Everything we know about human culture, society, and civilization has developed in the context of life on Earth. The moon, with its barren landscapes and harsh environment, represents a complete departure from that context. This shift in location, from our warm, blue planet to the stark, lifeless lunar surface, raises important questions about how humanity will evolve in response to these new conditions. It's not just about surviving in space, it's about how our cultures, ethics, and relationships might change in the process. This raises the question of what kind of societies lunar colonies will develop. Will they mirror the political systems of Earth, or will they adopt entirely new forms of governance? Will the moon become a place where international cooperation thrives, or will it be divided into competing territories claimed by different nations or corporations? One possibility is that the moon could serve as a testing ground for new forms of governance, where human society can be reimagined from the ground up, unencumbered by the historical baggage of Earth-bound political systems. In this sense, lunar colonies might not just be a technological experiment, but a social one as well. Moreover, the moon's unique environment could inspire new forms of culture and art. The experience of living on the moon, looking up at the Earth in the sky instead of the moon, experiencing the low-gravity environment, and adapting to the 29.5-day lunar day-night cycle, would be so different from life on Earth that it could lead to the creation of entirely new cultural expressions. Lunar music, art, literature, and even philosophy could emerge, reflecting the unique experiences and perspectives of those who live and work on the moon. These cultural developments would not only enrich the lives of lunar inhabitants, but could also provide new insights into what it means to be human. At the same time, the development of lunar colonies raises important ethical questions about humanity's responsibilities in space. The moon is a pristine environment, untouched by life or industry. As humans begin to build habitats, mines, and other infrastructure on the lunar surface, there is a risk of damaging this unique environment. Lunar dust, for example, is extremely fine and can be kicked up by human activity, potentially contaminating sensitive equipment, or even causing health problems for astronauts. The presence of humans on the moon could also alter the surface itself, as infrastructure is built and resources are extracted. In the rush to colonize the moon, it will be important to ensure that we do not repeat the mistakes of Earth, where industrialization has often led to environmental degradation. This brings up the broader question of humanity's role as stewards of the solar system. As we expand beyond Earth, we will need to develop new ethical frameworks to guide our interactions with other worlds. Should we treat the moon and other celestial bodies as resources to be exploited, or as places to be preserved and protected? What responsibilities do we have to future generations, both on Earth and on the moon, in terms of how we manage these resources? These are questions that will need to be addressed as we move forward with plans for lunar colonization and beyond. Another intriguing aspect of the moon's future is the potential for it to become a hub of scientific research and technological innovation. The moon offers unique advantages for scientific exploration, particularly in the fields of astronomy and planetary science. The far side of the moon, for example, is shielded from the radio noise generated by Earth, making it an ideal location for radio telescopes. A radio observatory on the far side of the moon could detect signals from the earliest stages of the universe, providing new insights into the formation of galaxies, stars, and planets. Similarly, the moon's stable environment and low gravity make it an ideal location for experiments in materials science, biology, and other fields that require conditions not found on Earth. The moon could also play a critical role in humanity's efforts to explore the rest of the solar system. Establishing a permanent base on the moon would provide a platform for launching missions to Mars and beyond. The moon's lower gravity makes it easier to launch spacecraft than from Earth, and the presence of water ice on the moon means that fuel and other supplies could be produced locally, reducing the need for expensive launches from Earth. A lunar base could serve as a staging point for missions to the outer planets, allowing humans to explore the solar system more efficiently and sustainably. In addition to its scientific and exploratory potential, the moon could also become a center of economic activity. The resources found on the moon, such as water ice, metals, and rare minerals, could be valuable both for lunar colonies and for industries on Earth. Helium-3, a rare isotope that is abundant on the moon, has been proposed as a potential fuel for nuclear fusion, a clean and virtually limitless source of energy. While the technology for fusion power is still in development, the prospect of mining the moon for helium-3 has generated significant interest, particularly in countries like China, which has announced plans to explore lunar mining. The development of lunar industries could also lead to the creation of new markets and opportunities for private companies. Already, companies like SpaceX and Blue Origin are working to develop the technologies needed for lunar exploration and resource extraction. These companies, along with others in the growing space industry, are positioning themselves to play a key role in the commercialization of the moon. This raises important questions about the role of private enterprise in space exploration. Should the moon's resources be open to exploitation by private companies? Or should they be managed as a common heritage for all of humanity? How should the profits from lunar industries be shared? And what safeguards should be put in place to ensure that the benefits of lunar exploration are distributed equitably? While the commercialization of the moon presents exciting possibilities, it also poses significant risks. The rush to exploit the moon's resources could lead to conflicts over ownership and control, particularly if multiple countries and companies lay claim to the same areas or resources. There is also the risk that the focus on economic gain could overshadow other important considerations, such as environmental protection, scientific research, and international cooperation. To avoid these pitfalls, it will be important to establish clear rules and regulations for lunar activities, ensuring that the moon is managed responsibly and sustainably. As we look to the future, the moon represents both a challenge and an opportunity. It is a place where humanity can test its limits, explore new frontiers, and develop the technologies and knowledge needed to thrive in space. But it is also a place that demands careful consideration and stewardship. How we approach the exploration and colonization of the moon will have far-reaching implications, not just for the future of space exploration, but for our understanding of ourselves and our place in the universe. The moon has always been a symbol of hope, wonder, and possibility. It has inspired poets, scientists, and dreamers for millennia, serving as a reminder of the vastness of the cosmos and the boundless potential of the human spirit. Now, as we prepare to return to the moon and establish a permanent presence there, we are taking the first steps toward realizing that potential. The journey to the moon is more than just a technological challenge. It is a journey of discovery, both outward and inward, as we seek to understand the universe and our place within it. In the years to come, the moon will become a new home for humanity, a place where we will learn to live, work, and explore in ways that were once the stuff of science fiction. It will be a place where we push the boundaries of what is possible, both technologically and socially, and where we lay the groundwork for the next great phase of human exploration. Whether we are building habitats, conducting scientific research, or mining resources, our activities on the moon will shape the future of humanity in profound and lasting ways. As we stand on the threshold of this new era, it is worth remembering that the moon is more than just a destination. It is a mirror that reflects our hopes, dreams, and aspirations. It is a reminder of what we can achieve when we work together, and of the limitless possibilities that lie ahead when we dare to dream big. The moon calls to us, just as it has called to countless generations before us, inviting us to explore, to discover, and to reach for the stars. As humanity's ambitions extend towards permanent lunar exploration, one of the key questions revolves around the fundamental changes to human physiology and psychology that living on the moon might entail. The moon's environment is drastically different from Earth's, and these differences will pose challenges not only to survival but also to how our bodies and minds adapt to long-term life in space. The most immediate and critical difference is gravity. On the moon, gravity is only 1/6 as strong as on Earth. While this reduced gravity will make moving heavy objects and building infrastructure easier, it will also have profound effects on the human body. Our muscles, bones, and cardiovascular systems are finely tuned to Earth's gravity, and they rely on that constant pull to maintain strength and function. In low-gravity environments, astronauts aboard the International Space Station, ISS, experience muscle atrophy and bone density loss due to the lack of constant resistance on their bodies. Over time, these effects can become severe enough to cause long-term health problems, such as osteoporosis or cardiovascular issues. While the moon's gravity is stronger than the microgravity experienced in space stations, the reduced force could still lead to similar health challenges for lunar settlers. Maintaining bone and muscle mass might require daily exercise regimes far more rigorous than what is needed on Earth. Moreover, researchers will need to study how long-term exposure to reduced gravity affects other physiological processes, such as circulation, digestion, and the immune system. Could living on the moon for years affect human reproduction, or would babies born on the moon develop differently due to the altered gravitational environment? These are questions that remain unanswered, but they are critical for the success of future lunar colonies. In addition to the physical challenges of low gravity, lunar settlers will also need to contend with the moon's extreme temperature fluctuations and lack of atmosphere. The lunar surface swings between temperature extremes, from blistering heat during the day, up to 127 degrees Celsius or 260 degrees Fahrenheit, to freezing cold at night, minus 173 degrees Celsius or minus 280 degrees Fahrenheit. These temperature changes occur over a lunar day, which is about 29.5 Earth days long. That means settlers would face 2 weeks of daylight followed by 2 weeks of darkness and freezing temperatures. Living in this environment will require highly specialized habitats that can regulate temperature, provide breathable air, and protect against radiation, another major hazard of lunar life. The moon has no atmosphere to shield its surface from the sun's harmful ultraviolet radiation or cosmic rays from deep space. On Earth, we are protected from these dangers by our atmosphere and magnetic field, but on the Moon, exposure to radiation is a constant threat. Prolonged exposure to cosmic radiation can lead to increased risks of cancer, radiation sickness, and damage to the body cells and tissues. This means that lunar habitats must be constructed with materials capable of blocking or absorbing radiation, or settlers will need to spend much of their time underground, where the Moon's surface can act as a natural shield. Radiation also has psychological implications, as it limits how much time people can spend outside their habitats, and restricts opportunities for recreation and relaxation. While venturing out onto the lunar surface in a space suit may be thrilling for the first few times, the novelty could wear off, leading to feelings of confinement. This has been an issue for astronauts aboard the ISS, who live in small, enclosed spaces for months at a time. The psychological strain of isolation, combined with the physical challenges of living in an extreme environment, can lead to stress, anxiety, and even depression. To mitigate these psychological effects, future lunar colonies will need to be designed with human well-being in mind. Habitats will likely need to include communal spaces for social interaction, recreational activities to reduce stress, and environments that mimic Earth as closely as possible, with simulated natural light and even gardens or greenhouses. Studies have shown that access to green spaces and natural light improves mental health, and this will be especially important for those living on the Moon, where the barren landscape offers little visual stimulation or connection to nature. In addition to concerns about isolation, the Moon's 29.5-day light-dark cycle poses another challenge: how to maintain a stable circadian rhythm. Humans are adapted to Earth's 24-hour day, and our bodies rely on this regular cycle of light and dark to regulate sleep, hormones, and overall well-being. On the Moon, settlers would need to artificially regulate their exposure to light to maintain a regular sleep schedule and avoid the fatigue and disorientation that can result from disrupted circadian rhythms. In this sense, future lunar colonies will have to carefully manage not just physical resources like food and water, but also psychological resources like light, sound, and social interaction. The psychological challenges of life on the Moon are likely to be as significant as the physical ones. Humans are social creatures, and prolonged isolation or confinement can lead to a range of mental health issues. Lunar settlers will be far from home, isolated from their families and friends, and cut off from the everyday experiences of life on Earth. While communication with Earth will be possible, the time delay, about 1.3 seconds each way, and the vast physical distance could make settlers feel more isolated than they might on the ISS or Mars. This isolation will be compounded by the extreme environment of the Moon, which offers few opportunities for outdoor recreation or exploration without significant risk and preparation. In this context, maintaining mental health will be crucial for the success of lunar colonies. This could mean developing new strategies for remote social interaction, using virtual reality or other technologies to simulate environments and experiences from Earth. It could also involve training settlers to cope with the psychological stresses of isolation, through mindfulness, meditation, or other mental health practices. In any case, the psychological well-being of lunar settlers will be just as important as their physical health, and it will require careful planning and support. As lunar colonies grow and become more established, there is the possibility of forming new social and cultural identities unique to the Moon. Just as different regions of Earth have distinct cultures, languages, and traditions, the Moon could become home to a new kind of human culture, shaped by the unique challenges and experiences of life in space. This lunar culture might develop its own art, music, literature, and philosophy, reflecting the perspectives of people who live on the frontier of human exploration. In this sense, the Moon could become a crucible for cultural innovation, where settlers experiment with new ways of living and interacting with each other. This new culture could also raise questions about identity and belonging. Will lunar settlers see themselves as citizens of Earth, or will they develop a new identity as lunarians or Moon folk? What will it mean to be from the Moon? And how will this identity intersect with national, ethnic, or other forms of identity that settlers bring with them from Earth? As lunar colonies grow and become more self-sufficient, they may begin to develop a sense of independence from Earth, leading to political and social movements that seek greater autonomy or even sovereignty for lunar communities. At the same time, the Moon could become a focal point for international cooperation and collaboration. The establishment of a permanent lunar base will likely involve the participation of multiple countries, as no single nation has the resources or expertise to do it alone. This collaboration could lead to new forms of international governance, where countries work together to manage the Moon's resources and infrastructure for the benefit of all humanity. Such cooperation could set an important precedent for future space exploration, demonstrating that the challenges of space can only be overcome through collective effort. The Moon has always held a special place in the human imagination. It has been a symbol of mystery, beauty, and longing, inspiring countless myths, stories, and songs throughout history. Now, as we prepare to return to the Moon and establish a permanent presence there, the symbolic significance of the Moon will evolve. It will become a place where humanity confronts its greatest challenges, both physical and psychological, and where we push the boundaries of what is possible. The Moon will no longer be just a distant object in the night sky, but a new frontier for human civilization, a place where we explore not just the universe, but also the limits of our own potential. As we stand on the cusp of this new era of lunar exploration, it is worth reflecting on the enormity of the task ahead. Establishing a permanent presence on the Moon will require unprecedented collaboration, innovation, and determination. It will challenge us to rethink how we live, work, and interact with each other, and it will force us to confront fundamental questions about what it means to be human in a new and unfamiliar environment. But the rewards are equally profound. By expanding our presence to the Moon, we will open up new opportunities for scientific discovery, economic growth, and cultural development. We will gain new insights into the nature of the universe and our place within it, and we will inspire future generations to continue exploring the unknown. The journey to the Moon is more than just a technological challenge. It is a journey of the human spirit, a testament to our ability to dream big and to make those dreams a reality. The Moon is calling, and humanity is ready to answer. As humanity prepares to answer the call of the Moon, the possibilities it holds extend far beyond scientific discovery or the allure of adventure. The Moon offers an opportunity to reshape how we think about exploration, the limits of human potential, and even the future of our species. A successful long-term presence on the Moon could lay the groundwork for humanity's expansion throughout the solar system. More importantly, it forces us to confront pressing questions about sustainability, ethics, and our collective aspirations. One of the key motivations for establishing a presence on the Moon is the pursuit of scientific knowledge. The Moon offers unique opportunities for research in astronomy, geology, biology, and even the study of Earth's history. Its surface contains a wealth of untapped resources and information that could help scientists answer fundamental questions about the formation of the solar system, the history of our planet, and the potential for life elsewhere in the universe. For example, lunar soil and rock samples could provide valuable insights into the early days of the Earth-Moon system, offering a clearer picture of the violent events that shaped our planetary neighborhood. The Moon also represents a pristine environment where scientific instruments can be deployed without the interference of Earth's atmosphere. Astronomers have long dreamed of building observatories on the Moon, taking advantage of its clear skies and stable platform to observe the universe in wavelengths that are blocked or distorted by Earth's atmosphere. A radio telescope on the far side of the Moon, shielded from Earth's radio emissions, could provide unprecedented observations of the cosmos, unlocking new discoveries about black holes, dark matter, and the early universe. Similarly, lunar-based observatories could be used to study exoplanets, potentially identifying signs of life on distant worlds. In addition to astronomy, the Moon is a prime location for testing the technologies and systems that will be needed for future exploration of Mars and beyond. The Moon's proximity to Earth makes it an ideal testing ground for life support systems, habitats, and resource utilization techniques. The ability to extract water from lunar ice, for example, is a critical step towards creating self-sustaining colonies. Water can be used for drinking, growing food, and even producing rocket fuel by splitting it into hydrogen and oxygen. Developing these capabilities on the moon will give us the experience and confidence needed to tackle the much greater challenges of Mars and other distant destinations. But beyond the practical benefits, there is a deeper, philosophical dimension to returning to the moon. Throughout history, exploration has been driven not just by the desire for knowledge, but by a sense of wonder, curiosity, and the human need to push boundaries. The moon represents one of the last great frontiers, a place where humanity can once again test its limits and imagine a future beyond the confines of Earth. This sense of adventure is a powerful motivator, inspiring people from all walks of life to dream of a world where humans are no longer confined to a single planet. Yet, as we push towards this new frontier, we must also confront the ethical questions that arise from our ambitions. One of the most pressing issues is how we manage the moon's resources. While the moon is often seen as a barren wasteland, it actually contains a number of valuable materials, including rare earth elements, helium-3, and water ice. The moon's surface has remained largely unchanged for billions of years, but human activity, whether in the form of landing spacecraft, building habitats, or mining resources, could have lasting consequences. The introduction of pollutants, the destruction of natural features, and the alteration of the lunar landscape could all have unforeseen effects, not only on the moon itself but also on the scientific value of its untouched environments. As we expand our presence on the moon, it will be important to balance the pursuit of progress with a commitment to preserving the natural beauty and scientific integrity of this celestial body. The moon represents a new frontier for human exploration, one that challenges us to think beyond the limitations of our current systems and imagine new possibilities for the future. It is a place where science, technology, and culture will converge, creating opportunities for discovery, innovation, and collaboration. As we prepare to return to the moon, we are not just embarking on a journey to another world, we are embarking on a journey into the future. A future where humanity is no longer bound to a single planet but is instead a spacefaring species, capable of exploring, inhabiting, and thriving in the vast expanse of the cosmos. The path to the moon will not be easy, and there will be many obstacles to overcome. But the rewards, scientific, economic, and cultural, are too great to ignore. The moon offers us a chance to expand our horizons, to push the boundaries of what is possible, and to inspire future generations to continue exploring the unknown. As we stand on the threshold of this new era of space exploration, we must approach it with a sense of wonder, curiosity, and responsibility, recognizing that the choices we make today will shape the future of humanity for generations to come. The moon has always been a symbol of possibility, a beacon in the night sky that reminds us of the vastness of the universe and the potential for discovery that lies beyond our immediate reach. Now, as we prepare to make the moon our home, we have the opportunity to turn that symbol into reality, to transform the dream of space exploration into a living, breathing human endeavor. The moon is calling, and humanity is ready to take the next giant leap. The journey to the moon, as humanity's next great leap, goes beyond simply landing and returning. It is about establishing a sustained and meaningful presence that pushes the boundaries of our technological capabilities, unites nations, and alters the trajectory of human civilization itself. To truly settle on the moon and call it a second home, we will need to address a host of challenges: scientific, technical, logistical, and philosophical. One of the most immediate challenges is building the infrastructure required for human habitation. Unlike Earth, the moon lacks a breathable atmosphere, stable temperatures, and liquid water on the surface. This means that every aspect of human survival, air, water, food, and protection from the harsh environment, will need to be engineered and carefully maintained. First, there is the question of life support systems. Humans require oxygen to breathe, water for drinking and hygiene, and food to sustain themselves. These resources are plentiful on Earth, but on the moon, they must either be brought from Earth or produced in situ using local materials. NASA and other space agencies are developing systems to extract water from lunar ice, which exists in permanently shadowed craters near the moon's poles. Water can be split into hydrogen and oxygen, not only providing drinking water but also generating oxygen for breathing and hydrogen for rocket fuel. Additionally, lunar habitats will need to be sealed and pressurized to maintain an Earth-like environment inside. These structures must also protect inhabitants from cosmic radiation and micrometeorite impacts, both of which are significant threats on the Moon's surface. Some proposals suggest building habitats underground or using lunar regolith, the fine, powdery dust that covers the Moon's surface, as a natural radiation shield. Other concepts include inflatable habitats covered with layers of regolith or robotic 3D printed domes made from lunar materials. Energy generation is another critical factor. Solar power is an obvious choice, as the Moon receives direct sunlight for roughly 2 weeks at a time. However, during the long lunar night, which also lasts around 2 weeks, alternative energy storage systems, such as batteries or fuel cells, will be essential. Scientists are exploring various methods of storing energy during the day to be used at night, including advanced battery technologies and thermal energy storage systems that capture and release heat. The harsh temperature extremes on the Moon pose additional challenges. The lunar day can see temperatures rise above 100 degrees Celsius, while at night, temperatures plummet to -150 degrees Celsius. Any habitat will need to be heavily insulated and equipped with systems that can regulate temperature to maintain a stable, livable environment. Moreover, astronauts will need protective suits capable of handling these extremes when they venture outside their habitats. Food production is another essential concern. While astronauts on short-term missions to the Moon can bring food from Earth, long-term settlements will require sustainable agricultural systems. Researchers are experimenting with growing crops in lunar soil simulants to understand how plants can be cultivated in low-gravity environments with limited water and nutrient supplies. Hydroponic and aeroponic systems, methods of growing plants without soil, using nutrient-rich water or mist, may be essential for producing food on the Moon. The ability to grow food locally will reduce the need for costly resupply missions from Earth and ensure the long-term sustainability of lunar colonies. The psychological well-being of lunar settlers is another key consideration. Living on the Moon, with its isolation, confinement, and lack of familiar landscapes, will be a radically different experience from life on Earth. Astronauts on the International Space Station, ISS, already face challenges related to the isolation of long-duration spaceflight, but the Moon presents additional challenges, given its greater distance from Earth and the longer missions that would be required. To address these issues, lunar habitats must be designed with human psychology in mind. Access to natural light, opportunities for physical exercise, and social interaction will be important for maintaining mental health. Virtual reality systems may be used to simulate Earth-like environments, allowing settlers to escape the barren lunar landscape for brief periods. Communication with Earth, while delayed by a few seconds, will still be possible, allowing settlers to stay connected with family, friends, and mission control. These psychological support systems will be crucial for ensuring that lunar colonists remain healthy and productive over the long term. As we look beyond the initial stages of lunar exploration, the vision of a thriving lunar colony takes shape. Such a colony could serve as a hub for scientific research, industry, and even tourism. A permanently inhabited base on the Moon could host a rotating crew of scientists, engineers, and tourists, all contributing to a growing lunar economy. The Moon's unique low-gravity environment could enable new manufacturing techniques, particularly in fields like 3D printing, metallurgy, and materials science. Factories on the Moon could produce goods that are difficult or impossible to make on Earth, such as super-strong alloys or specialized electronic components. One of the most exciting possibilities is the use of the Moon as a launching point for missions deeper into the solar system. The Moon's lower gravity means that it takes much less energy to launch a spacecraft from its surface than from Earth. This makes it an ideal location for assembling and refueling spacecraft bound for Mars, asteroids, or even the outer planets. A lunar spaceport could become the gateway to the rest of the solar system, enabling humanity to establish a permanent presence on multiple celestial bodies. Of course, all of this will require significant investment and international cooperation. No single country or company can develop the moon's infrastructure alone. The scale of the endeavor demands collaboration on a global level, with nations and private companies pooling their resources, expertise, and technologies. Fortunately, there is already a growing momentum behind such cooperation. NASA's Artemis program aims to return humans to the moon by 2025, and it has partnered with space agencies from Europe, Japan, and Canada, as well as private companies like SpaceX and Blue Origin. Other countries, including China and Russia, have announced their own plans for lunar exploration and settlement. The private sector will also play a crucial role in the commercialization of the moon. Companies like SpaceX, Blue Origin, and Astrobotic are developing technologies for lunar landers, habitats, and resource extraction. The rise of space tourism could see private individuals and companies funding missions to the moon for commercial purposes, further accelerating the development of lunar infrastructure. In the long term, the moon could become a key part of the global economy, with industries ranging from mining and manufacturing to tourism and research all contributing to a thriving lunar economy. But as we move closer to making lunar colonization a reality, we must also consider the broader philosophical implications of becoming a multiplanetary species. The moon represents the first step in humanity's expansion beyond Earth, and it raises profound questions about our relationship with the cosmos. What responsibilities do we have as we venture into space? How should we govern new societies on other worlds? And what kind of future do we want to create for ourselves as a space-faring civilization? These are not just abstract questions. They are practical issues that will need to be addressed as we establish settlements on the moon and, eventually, on Mars and beyond. The exploration and settlement of the moon will force us to rethink our assumptions about economics and ethics in a space-faring context. For example, the governance of lunar colonies will require new frameworks that balance the interests of individual settlers, private companies, and nation-states. The development of lunar resources will need to be done in a way that is sustainable and equitable, ensuring that the benefits of space exploration are shared by all of humanity. At the same time, the exploration of the moon invites us to reflect on our place in the universe. For millennia, humans have looked up at the moon and wondered what lies beyond. Now we stand on the cusp of answering that question, not just with probes and robots, but with human footsteps on the lunar surface. This journey is not just about technology or economics. It is about the spirit of exploration, the desire to push beyond the known, and the belief that humanity's future lies in the stars. The moon is a stepping stone, a testing ground, and a beacon of hope for future generations. It represents the next great adventure for humanity, one that will challenge us to think creatively, work together, and dream big. As we prepare to return to the moon, we are not just reaching for a distant rock in the sky. We are reaching for a future where humanity thrives among the stars. The moon is calling, and humanity is ready to answer. The journey to the moon, while rooted in science and technology, also taps into something much deeper within the human psyche, our innate desire to explore, to push boundaries, and to understand the unknown. Since time immemorial, the moon has served as a symbol of mystery, wonder, and aspiration. Civilizations across the world have looked to it not only for its beauty, but also for its influence on human culture. The moon's phases have been used to measure time, guide agricultural practices, and structure human life in ways that have persisted for thousands of years. But now, we stand on the threshold of transforming that relationship from one of distant awe to direct interaction. The philosophical questions that arise from lunar exploration are profound and multifaceted. On a practical level, as humanity prepares to establish a sustained presence on the moon, we must reconsider our relationship with the natural world and the ethics of exploration. The moon, like any natural environment, has intrinsic value. Its landscapes, its history, and its untouched nature are precious in their own right. As we contemplate mining its resources, constructing habitats, and building industries, we must consider the consequences of human activity on this celestial body. Will we respect the moon's unique environment, or will we repeat the mistakes of Earth, depleting resources, altering ecosystems, and leaving behind waste? The moon presents an opportunity for humanity to pioneer a new kind of exploration, one that is sustainable, respectful, and guided by principles of stewardship. The international community must come together to establish clear rules for how the moon is used, ensuring that future generations can benefit from its resources and beauty without suffering from the consequences of overexploitation. Living on the moon, and eventually on other planets, will require humans to adapt to radically different environments. The experience of living in low gravity, isolated from the rest of humanity, with limited resources and exposure to the harsh realities of space, will shape the psychology, culture, and society of lunar settlers in ways we can only begin to imagine. Some scientists and futurists have even speculated that humans may eventually evolve into a new species, adapted to life in space, with physical and psychological traits distinct from Earth-bound humans. The moon, as our first step beyond Earth, will serve as the testing ground for this transformation. Lunar settlers will need to develop new ways of living, working, and interacting with each other. They will form new communities, shaped by the unique challenges of life on the moon. Over time, these communities may develop distinct cultural identities, with their own traditions, values, and practices. Just as the frontier experience shaped the development of nations on Earth, the lunar frontier may give rise to new forms of governance, economy, and social organization. At the same time, life on the moon will force us to confront the limits of human endurance and ingenuity. The moon's environment is unforgiving, with no air to breathe, extreme temperatures, and high levels of radiation. Human settlers will be dependent on technology for their survival, relying on complex systems to provide air, water, food, and protection. Any failure in these systems could be catastrophic, leading to loss of life and threatening the entire settlement. This dependence on technology raises ethical questions about the balance between human autonomy and machine control. On Earth, humans have historically lived in environments where they have a degree of control over their surroundings. On the moon, this balance will shift, with technology playing a dominant role in mediating the relationship between humans and their environment. Settlers will need to trust in their machines to keep them alive, while also developing the skills and knowledge to repair and maintain these systems in the event of failure. Moreover, the moon's settlement will force us to rethink our relationship with Earth. As we establish a presence on the moon, we will still be deeply connected to our home planet, both physically and emotionally. Earth will remain the source of many of the resources needed to sustain life on the moon, and lunar settlers will continue to look to Earth for support, communication, and cultural ties. However, the experience of living on the moon, seeing Earth as a distant, fragile blue sphere in the vastness of space, will likely foster a new sense of environmental consciousness. From the moon, Earth's boundaries, national, political, and cultural, disappear. The planet appears as a unified whole, a fragile oasis of life in the hostile environment of space. This perspective has the potential to reshape how humanity thinks about itself and its place in the universe. The overview effect, a phenomenon reported by astronauts who have seen Earth from space, often leads to a profound shift in consciousness, a recognition of the interconnectedness of all life and the need to protect our home planet. As more humans experience the moon and view Earth from this vantage point, it is possible that a new global ethic will emerge, one that emphasizes cooperation, sustainability, and the protection of the planet's ecosystems. The moon, as our stepping stone to the stars, may help us to better appreciate the uniqueness and fragility of life on Earth. In this way, lunar exploration is not just about expanding outward into space, it is also about looking inward, deepening our understanding of what it means to be human and our responsibilities to each other and the planet. Looking further into the future, the moon may also serve as a catalyst for deeper exploration of the solar system. Establishing a permanent presence on the moon will provide valuable experience and technologies that can be applied to missions to Mars, asteroids, and beyond. The moon's low gravity and proximity to Earth make it an ideal location for testing the technologies and strategies needed for long-duration space travel. Lunar resources, such as water, ice, and oxygen, could be used to refuel spacecraft, reducing the cost and complexity of missions to more distant destinations. In this sense, The moon is not just a destination, it is a gateway to the wider universe. By mastering the challenges of living and working on the moon, humanity will take its first steps toward becoming a truly interplanetary species. The lessons learned from the moon will pave the way for the exploration of Mars, the colonization of the asteroid belt, and ultimately, the journey to the outer planets and their moons. The moon, then, represents the beginning of a new era in human history. It is the place where we will begin to build the infrastructure and knowledge needed to explore the cosmos. But more than that, it is a place that will challenge us to redefine what it means to be human. It will force us to confront the limits of our technology, our understanding of the universe, and our capacity for cooperation and innovation. As we stand on the brink of this new frontier, we are reminded of the words spoken by astronaut Neil Armstrong during the Apollo 11 mission. That's one small step for man, one giant leap for mankind. The steps we take on the moon in the coming decades will be small in the context of the vastness of space, but they will be giant leaps for the future of humanity. The moon is calling, and it is up to us to answer, to rise to the challenge, to push the boundaries of what is possible, and to take our place among the stars. As humanity sets its sights on the moon, the endeavor extends beyond mere survival or exploration. It represents a profound transformation in our collective consciousness and capabilities. The moon's harsh environment and isolation present unique challenges, but they also offer unparalleled opportunities for growth, innovation, and discovery. This continuation delves into the broader implications of lunar colonization, exploring its potential impact on science, society, and our future as a spacefaring civilization. Scientific advances and research. The moon's proximity and relatively stable environment provide an ideal platform for conducting scientific research that would be difficult or impossible to perform elsewhere. One of the most exciting possibilities is the study of the moon's geology. The lunar surface preserves a record of the early solar system, offering insights into the formation and evolution of planetary bodies. Samples of lunar regolith and rock returned from Apollo missions have already provided valuable data, but ongoing research promises to reveal even more. Lunar exploration can also shed light on the history of the moon itself. Understanding the moon's geological processes, such as volcanic activity and impact cratering, can inform our knowledge of planetary science and the formation of other celestial bodies. This research has implications not only for the moon but also for the broader understanding of the solar system's evolution. Another significant area of research is the study of the moon's potential resources. The discovery of water ice in permanently shadowed lunar craters has transformed our understanding of the moon's resource potential. Water is crucial for supporting human life and can be split into hydrogen and oxygen, providing a source of rocket fuel for deep space missions. The moon's regolith also contains valuable materials such as helium-3, which has potential applications in nuclear fusion. Extracting and utilizing these resources could pave the way for sustainable space exploration and provide a testbed for technologies that will be used in future missions to Mars and beyond. Technological innovations. The challenges of living and working on the moon will drive the development of new technologies with applications far beyond space exploration. The development of advanced life support systems, radiation shielding, and habitat construction will lead to innovations that could benefit life on Earth. For instance, technologies designed to recycle water and air in lunar habitats may find applications in resource-scarce regions on Earth, improving sustainability and efficiency in various industries. Lunar colonization will also drive advancements in robotics and artificial intelligence. To minimize risk and enhance efficiency, robots will be used for tasks such as constructing habitats, mining resources, and performing maintenance. These robots will need to operate autonomously in harsh lunar conditions, driving innovation in AI, machine learning, and robotics. The technologies developed for lunar robots will likely have applications in other fields, including disaster response, deep-sea exploration, and remote operations. Furthermore, the need for reliable communication between Earth and the Moon will spur advancements in telecommunications technology. Developing high-speed, long-distance communication systems will improve data transmission rates and reduce latency, benefiting global communications and internet infrastructure. These technologies will support not only space missions but also enhance connectivity in remote and underserved regions on Earth. Societal implications. Lunar colonization will have profound societal implications, reshaping how we think about our place in the universe and our relationship with Earth. The experience of living on the Moon will challenge our assumptions about human adaptability and resilience. As settlers contend with the Moon's extreme environment and isolation, they will develop new ways of living, working, and interacting. This experience will influence our understanding of human psychology and social dynamics, offering valuable insights into how people adapt to extreme conditions and form communities in unfamiliar environments. The Moon's settlement will also prompt a reevaluation of our cultural and philosophical perspectives. The sight of Earth from the Moon, an isolated, fragile sphere floating in the vastness of space, has the potential to foster a new sense of global unity and environmental consciousness. Astronauts who have seen Earth from space often describe a profound shift in their perspective, recognizing the interconnectedness of all life and the need to protect our planet. As more people experience the Moon and view Earth from this vantage point, it is likely to inspire a renewed commitment to environmental stewardship and international cooperation. The Moon's colonization could also influence cultural and artistic expression. The unique environment of the Moon, combined with the experience of living in space, will inspire new forms of art, literature, and media. Just as space exploration has inspired countless works of science fiction and speculative fiction, the reality of living on the Moon will undoubtedly spark new creative endeavors. These works will reflect the challenges, triumphs, and wonders of lunar life, contributing to our collective cultural heritage. Ethical considerations. As we advance toward lunar colonization, ethical considerations will play a crucial role in shaping the future of space exploration. The potential for environmental impact, resource exploitation, and human rights violations must be addressed with care and foresight. Ensuring that lunar activities are conducted responsibly and sustainably will require collaboration among international stakeholders, scientists, engineers, and ethicists. One key ethical consideration is the impact of human activity on the Moon's environment. While the Moon is an airless, seemingly barren world, it is not without its own form of ecological balance. The introduction of human activity, such as construction, mining, and waste disposal, could disrupt this balance. Developing and implementing protocols to minimize environmental impact will be essential to preserving the Moon's integrity and ensuring that future generations can continue to explore and benefit from its resources. Another ethical issue involves the equitable distribution of lunar resources and benefits. As space exploration becomes more commercialized, there is a risk that the Moon's resources could be exploited by a few powerful entities, potentially leading to inequality and conflict. Establishing clear guidelines for the fair and responsible use of lunar resources will be crucial for ensuring that the benefits of space exploration are shared broadly and equitably. The rights and well-being of lunar settlers will also need to be carefully considered. Living on the Moon will entail significant risks and challenges, and ensuring the health and safety of settlers will be a top priority. Providing adequate support, protection, and compensation for those who take on the challenges of lunar life will be essential for maintaining morale and ensuring the success of long-term missions. The future of lunar exploration. Looking ahead, the Moon's role in humanity's spacefaring future will continue to evolve. As we establish a permanent presence on the Moon, the focus will shift from exploration to expansion and development. The Moon will serve as a testing ground for new technologies, a hub for scientific research, and a stepping stone for deeper space exploration. In the coming decades, we can expect to see the Moon become a focal point for international collaboration and commercial activity. Space agencies, private companies, and international organizations will work together to build and expand lunar infrastructure, conduct research, and develop new technologies. The Moon will become a vibrant center of activity, with research facilities, industrial operations, and human settlements all contributing to the growing lunar economy. As humanity pushes further into the solar system, the Moon will serve as a critical launch point for missions to Mars and beyond. The experience gained from living and working on the moon will inform the design and implementation of future missions, helping to address the challenges of long-duration space travel and off-world habitation. The moon's resources will play a crucial role in supporting these missions, providing the materials and energy needed for exploration and settlement on other celestial bodies. Ultimately, the moon represents the beginning of a new era for humanity, a time when we are no longer confined to our home planet but are actively exploring and inhabiting the broader universe. The journey to the moon is not just a scientific and technological endeavor. It is a transformative experience that will shape the future of human civilization. As we look to the stars, we are reminded of the words of Carl Sagan, who said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." The moon, as our first step into the cosmos, is a symbol of our quest to understand the universe and our place within it. It represents the boundless potential of human ingenuity and the spirit of exploration that drives us to reach for the stars. In the years and decades to come, the moon will become a testament to our collective achievements and aspirations. It will stand as a beacon of human curiosity, resilience, and determination, a reminder that, no matter how distant or challenging the frontier, humanity is capable of overcoming obstacles and achieving greatness. As we embark on this new chapter in our exploration of the moon, we carry with us the hopes and dreams of generations past and present. The journey to the moon is a reflection of our enduring quest for knowledge, our desire to push the boundaries of what is possible, and our commitment to building a future where humanity can thrive among the stars. The moon is calling, and it is up to us to answer, to embrace the challenges, seize the opportunities, and forge a new path into the cosmos. As humanity advances its presence on the moon, we must consider the broad and intricate tapestry of implications this endeavor holds for science, technology, society, and our collective future. The moon, with its ancient allure and modern significance, is not just a celestial body but a cornerstone for a new era of human exploration and potential. This continuation explores in depth the multifaceted aspects of lunar exploration, focusing on long-term implications, the intersection of technology and society, and the philosophical and existential questions that arise as we venture further into space. Scientific research and technological innovation. The moon's role as a scientific laboratory will extend far beyond its geological history. The lunar surface provides an opportunity to study phenomena that are difficult to replicate on Earth. For instance, the moon's low gravity and lack of atmosphere make it an ideal site for observing cosmic rays and solar radiation. Research in these areas could lead to breakthroughs in our understanding of space weather, radiation shielding, and its effects on living organisms. Additionally, the moon's unique environment presents opportunities to investigate fundamental physics. Experiments conducted in its low-gravity setting could shed light on phenomena such as dark matter and antimatter. For instance, the Lunar Laser Ranging Experiment, which involves bouncing lasers off retroreflectors placed on the moon during the Apollo missions, helps test theories of gravity and relativity. Such experiments could potentially lead to a deeper understanding of the fundamental forces that govern the universe. The development of new technologies for lunar exploration will drive progress in various fields. Innovations in robotics, artificial intelligence, and materials science will emerge as we address the challenges of sustaining human life on the moon. For example, advances in robotics will enable the automation of complex tasks such as construction and maintenance of lunar habitats, reducing the need for human presence in hazardous environments. These technologies will have applications far beyond the moon, potentially transforming industries on Earth and contributing to advancements in fields such as autonomous vehicles, manufacturing, and healthcare. Moreover, the moon's potential as a site for scientific observation will be enhanced by the construction of observatories and research stations. The absence of an atmosphere and light pollution makes the moon an ideal location for space telescopes and radio antennas. Such facilities could provide unprecedented views of the universe, enabling astronomers to study distant galaxies, exoplanets, and cosmic phenomena with unparalleled clarity. This will not only expand our knowledge of the cosmos but also inspire future generations of scientists and explorers. societal impact, and cultural transformation. The establishment of a lunar base will have profound effects on human society and culture. As people begin to live and work on the moon, new forms of social organization, governance, and cultural expression will emerge. Lunar settlers will need to develop innovative solutions for living in an environment that is isolated from Earth and characterized by limited resources. This experience will shape their social dynamics, creating unique communities with their own customs, norms, and values. The moon's colonization will also influence cultural and artistic expression. The experience of living in space, combined with the moon's stark and otherworldly landscape, will inspire new forms of art, literature, and media. Artists and writers will explore themes of isolation, exploration, and the human condition in ways that reflect the unique challenges and opportunities of lunar life. These creative works will contribute to a broader cultural dialogue about humanity's place in the universe and the implications of our ventures into space. Furthermore, the moon's role as a symbol of human achievement and aspiration will likely lead to a renewed sense of global unity and cooperation. The challenges of lunar exploration and colonization will require collaboration among nations, organizations, and individuals from diverse backgrounds. This collaborative spirit will foster international partnerships and promote a shared vision for the future of space exploration. The moon, as a common goal, will serve as a unifying force, encouraging humanity to work together to achieve its dreams. Ethical and philosophical considerations. The ethical and philosophical dimensions of lunar colonization are profound and complex. As we venture into space, we must grapple with questions of stewardship, responsibility, and the impact of our actions on the moon and beyond. Ensuring that our exploration and utilization of lunar resources are conducted in a manner that respects the moon's intrinsic value and preserves its environment will be crucial. One key ethical consideration is the potential for contamination of the moon's environment. The introduction of Earth-based microorganisms, pollutants, and waste could have unforeseen consequences for the lunar ecosystem. Developing protocols for planetary protection and ensuring that our activities do not disrupt the moon's natural state will be essential for maintaining its scientific and environmental integrity. Another ethical issue involves the distribution of benefits and resources derived from lunar exploration. As space exploration becomes more commercialized, there is a risk that the moon's resources could be exploited for the benefit of a few powerful entities, potentially leading to inequality and conflict. Establishing fair and transparent mechanisms for the allocation of lunar resources and ensuring that the benefits of space exploration are shared equitably will be important for promoting global cooperation and social justice. The philosophical implications of lunar exploration extend to our understanding of human identity and purpose. The experience of living and working on the moon will challenge our notions of what it means to be human and our relationship with the cosmos. The moon's stark and alien environment will prompt reflections on the nature of existence, the limits of human capability, and the meaning of exploration and discovery. As we venture into space, we are confronted with fundamental questions about our place in the universe and our role as stewards of our home planet. The moon, as our first step beyond Earth, represents both a physical and symbolic boundary. It challenges us to confront our aspirations, fears, and responsibilities as we chart a course for the future. The road ahead. Looking to the future, the moon will serve as a launchpad for humanity's broader exploration of the solar system. The technologies, knowledge, and experience gained from lunar exploration will pave the way for missions to Mars, asteroids, and other celestial bodies. The moon's role as a testing ground for space technologies and a source of resources will be crucial for the success of these ambitious endeavors. As we establish a permanent presence on the moon, we will need to address the challenges of long-duration space travel and off-world habitation. Developing sustainable life support systems, advanced propulsion technologies, and effective radiation shielding will be essential for ensuring the safety and well-being of future space explorers. The lessons learned from lunar missions will inform the design and implementation of missions to more distant destinations, helping to address the complexities of human spaceflight and exploration. The moon's role as a center of scientific research, technological innovation, and cultural expression will continue to evolve as we advance our presence on this celestial body. The experience of living and working on the moon will shape our understanding of the universe and our place within it, inspiring new discoveries, technologies, and creative endeavors. Ultimately, the moon represents the beginning of a new era in human exploration and discovery. It is a testament to our collective achievements, aspirations, and potential. As we look to the stars, we are reminded of the words of astronaut Buzz Aldrin, who said, "The moon is the stepping stone to Mars." The journey to the moon is not just a destination but a gateway to a broader exploration of the cosmos. The challenges and opportunities of lunar exploration will shape the future of humanity, driving progress in science, technology, and culture. The moon, with its ancient allure and modern significance, will continue to inspire and challenge us as we strive to understand the universe and our place within it. As we embark on this new chapter in our exploration of space, we carry with us the hopes and dreams of generations past and present, forging a path toward a future where humanity can thrive among the stars. The moon is more than a destination. It is a symbol of human curiosity, resilience, and determination. It represents the boundless potential of our species and the spirit of exploration that drives us to reach for the stars. As we continue our journey to the moon and beyond, we are guided by the vision of a future where humanity can explore, learn, and thrive in the cosmos, building a legacy of discovery and achievement for generations to come. As humanity ventures further into the cosmos, the moon will increasingly serve as a crucial cornerstone of our space exploration and development endeavors. This continuation explores how the moon's role will expand over time, its impact on various aspects of human knowledge and society, and the long-term vision for our species as we transition from Earth-bound existence to a multiplanetary civilization. Lunar infrastructure and its expanding role. As the moon becomes more accessible, the development of its infrastructure will play a pivotal role in supporting long-term habitation and exploration. Lunar bases will evolve from temporary outposts to permanent settlements equipped with advanced life support systems, sustainable energy sources, and extensive research facilities. These bases will be designed to support a growing population, accommodate scientific and industrial activities, and serve as hubs for further space exploration. The construction of lunar habitats will require the development of new building materials and techniques adapted to the moon's harsh environment. In situ resource utilization (ISRU) will be key to reducing dependence on supplies from Earth. Technologies for mining and processing lunar regolith, extracting water from ice deposits, and generating oxygen and fuel from local resources will be essential. Advances in 3D printing and construction robotics will enable the creation of durable, efficient habitats using lunar materials, minimizing the need for imported resources. Lunar infrastructure will also include research laboratories focused on a wide range of scientific disciplines. These labs will facilitate experiments in fields such as astrobiology, materials science, and medicine. For instance, studying how low gravity affects biological organisms can provide insights into human health and aging, potentially leading to breakthroughs in medical science and healthcare. The moon's role as a staging ground for deeper space missions will be a critical aspect of its infrastructure development. Lunar launch sites and refueling stations will support missions to Mars, the outer planets, and beyond. By leveraging the moon's lower gravity and abundant resources, we can reduce the cost and complexity of interplanetary travel, making space exploration more feasible and sustainable. Cultural and societal impact. The moon's influence on human culture and society will extend beyond the realm of science and technology. As humanity establishes a presence on the moon, the cultural significance of this celestial body will evolve, shaping our collective identity and worldview. The experience of living and working on the moon will inspire new forms of cultural expression, including literature, art, music, and film. These creative works will reflect the challenges, triumphs, and experiences of lunar life, contributing to a rich tapestry of space-related culture. The moon's unique environment and the experience of being away from Earth will provide fresh perspectives on themes such as isolation, exploration, and human resilience. Educational and outreach programs will play a crucial role in inspiring future generations and fostering a sense of connection to space exploration. Schools, museums, and media will engage young people with the wonders of lunar exploration, encouraging interest in science, technology, engineering, and mathematics (STEM) fields. By fostering curiosity and ambition, we can ensure a continued pipeline of talent and innovation to drive the future of space exploration. The moon will also influence societal values and norms. As humanity ventures into space, our understanding of our place in the universe and our responsibilities as stewards of our planet will be challenged and expanded. The sight of Earth from the moon, a fragile blue dot in the vastness of space, will continue to inspire a sense of global unity and environmental consciousness. This perspective will encourage a greater emphasis on sustainability, cooperation, and the protection of our home planet. Philosophical and existential reflections. The exploration and colonization of the moon raise profound philosophical and existential questions about humanity's place in the universe and our purpose as a species. The experience of venturing beyond Earth and establishing a presence on another celestial body challenges our understanding of existence and our relationship with the cosmos. One key philosophical question is the nature of human identity and the impact of living in space. The moon's environment will challenge our notions of what it means to be human, as we adapt to new physical and psychological conditions. The experience of living in isolation, away from Earth, will prompt reflections on the nature of human connection, the significance of home, and the meaning of exploration. The quest for knowledge and the drive to explore new frontiers are deeply ingrained aspects of the human spirit. The moon represents a tangible step in this quest, offering a unique opportunity to expand our understanding of the universe and our place within it. The pursuit of space exploration reflects our innate curiosity and desire to push the boundaries of what is possible, seeking answers to fundamental questions about the nature of existence and the future of our species. The moon also serves as a symbol of our potential for growth and achievement. As we establish a permanent presence on the celestial body, we demonstrate our capability to overcome challenges and transform our vision of the future into reality. The journey to the moon is not just a scientific and technological endeavor but a testament to the resilience, creativity, and ambition of humanity. The vision for a multiplanetary future. The moon is a crucial stepping stone in humanity's journey toward becoming a multiplanetary species. As we build on our achievements in lunar exploration, the vision for our future will extend to Mars, the outer planets, and beyond. The technologies, knowledge, and experience gained from lunar missions will be instrumental in realizing this vision. Mars represents the next major frontier in human exploration. The challenges of living on Mars, including its harsh environment, thin atmosphere, and long-duration space travel, will require advancements in technology and infrastructure. The lessons learned from lunar colonization, such as developing life support systems, managing resources, and building sustainable habitats, will inform the design and implementation of Martian missions. The establishment of a human presence on Mars will mark a significant milestone in our journey as a spacefaring civilization. It will require international collaboration, scientific research, and technological innovation to address the complexities of Martian exploration and settlement. The experience gained from lunar missions will be invaluable in preparing for the challenges of living on another planet and expanding our reach into the solar system. Beyond Mars, the exploration of asteroids, the outer planets, and their moons will open new avenues for scientific discovery and resource utilization. Missions to these distant destinations will provide insights into the formation and evolution of the solar system, as well as opportunities for mining and exploration. The technologies and capabilities developed for lunar and Martian exploration will be crucial in supporting these ambitious endeavors. The legacy of lunar exploration. As we look to the future, the legacy of lunar exploration will be defined by our achievements, innovations, and contributions to human knowledge and society. The moon represents both a tangible destination and a symbol of our collective aspirations and potential. It stands as a testament to our curiosity, resilience, and determination to explore the cosmos and expand our understanding of the universe. The legacy of lunar exploration will be reflected in the advancements we make in science, technology, and culture. The technologies developed for lunar missions will drive progress in various fields, from robotics and materials science to telecommunications and healthcare. The scientific research conducted on the Moon will expand our knowledge of the cosmos and inform future missions to other celestial bodies. The cultural impact of lunar exploration will inspire future generations and shape our collective identity. The creative works, educational programs, and outreach initiatives that emerge from our lunar endeavors will contribute to a rich and diverse tapestry of space-related culture. The Moon's role as a symbol of human achievement and aspiration will continue to inspire and challenge us as we strive to reach new frontiers. In conclusion, the exploration and colonization of the Moon represent a pivotal chapter in humanity's journey into the cosmos. The challenges and opportunities of lunar exploration will shape the future of our species, driving advancements in science, technology, and culture. As we establish a permanent presence on the Moon and look beyond to other celestial destinations, we will build on our achievements and strive to realize our vision of a multiplanetary future. The Moon, with its ancient allure and modern significance, will continue to inspire and guide us as we explore the universe and seek to understand our place within it. It represents the boundless potential of human ingenuity and the spirit of exploration that drives us to reach for the stars. As we embark on this new chapter in our journey, we carry with us the hopes and dreams of generations past and present, forging a path toward a future where humanity can thrive among the stars. As we advance further into lunar exploration and settlement, the Moon will increasingly shape and redefine our understanding of our place in the universe. The ongoing endeavors to establish a permanent human presence on the Moon will not only push the boundaries of technological innovation but also inspire profound changes in our societal structures, cultural values, and philosophical outlook. Expanding lunar settlements and the quest for sustainability. The expansion of lunar settlements will necessitate a focus on sustainability, as the challenges of living on the Moon require innovative solutions to ensure long-term viability. The establishment of permanent bases will involve intricate planning and development of infrastructure to support human life in a harsh, resource-limited environment. The development of sustainable energy sources will be critical for lunar settlements. Solar power, harnessed through advanced photovoltaic technology, will be a primary energy source due to the Moon's exposure to the Sun for extended periods. However, lunar nights, which last approximately 14 Earth days, present challenges for energy storage and management. Innovations in energy storage systems, such as advanced batteries or regenerative fuel cells, will be essential to provide continuous power during these dark periods. Water is another vital resource for lunar colonists. The discovery of ice deposits at the Moon's poles has opened the possibility of extracting and utilizing water for drinking, growing food, and generating oxygen and hydrogen through electrolysis. The establishment of ice mining and processing facilities will be crucial for ensuring a stable supply of this essential resource. Agriculture will play a significant role in supporting human life on the Moon. Growing food in lunar greenhouses will require advancements in hydroponics, aeroponics, and other soil-less cultivation techniques. Research into plant growth in low gravity and the development of efficient nutrient delivery systems will be key to creating a sustainable food supply for lunar inhabitants. The management of waste and recycling will be another critical aspect of lunar sustainability. Closed-loop systems that recycle waste products and minimize environmental impact will be essential for maintaining a habitable environment. The development of advanced waste processing technologies and recycling systems will help reduce reliance on external supplies and enhance the self-sufficiency of lunar bases. Lunar research and innovation. The Moon's unique environment offers unparalleled opportunities for scientific research and technological innovation. Lunar research will encompass a wide range of fields, from fundamental physics and astronomy to life sciences and materials engineering. The absence of an atmosphere on the Moon makes it an ideal location for astronomical observations. The construction of lunar observatories, free from the distortions caused by Earth's atmosphere, will provide unprecedented views of the cosmos. These observatories will enable astronomers to study celestial phenomena with greater precision, leading to new discoveries about the universe's formation, structure, and evolution. Lunar research will also focus on understanding the Moon's geological history. The study of lunar rocks and regolith will provide insights into the early solar system and the processes that shaped planetary bodies. The analysis of impact craters, volcanic features, and mineral deposits will enhance our knowledge of lunar geology and contribute to broader planetary science research. In the realm of materials science, the Moon's low gravity and unique conditions will enable experiments that are not possible on Earth. Researchers will investigate the behavior of materials under extreme temperatures, vacuum conditions, and reduced gravity. This research could lead to the development of new materials with applications in various industries, from aerospace to manufacturing. Life sciences research on the Moon will explore the effects of prolonged exposure to low gravity and radiation on biological organisms. Studies of human health, physiology, and psychology in space will inform the design of future space missions and support the development of countermeasures to mitigate health risks associated with long-duration space travel. Economic development and space industry. The economic development of the Moon will be driven by the growth of the space industry and the commercialization of lunar resources. The establishment of lunar bases and mining operations will create new markets and business opportunities, transforming the space economy. Lunar mining will focus on extracting valuable resources such as rare earth elements, platinum group metals, and helium-3. These materials are crucial for various technologies and industries, including electronics, energy production, and propulsion systems. The extraction and processing of these resources will require advanced mining technologies and infrastructure, paving the way for the growth of a lunar mining industry. The commercialization of lunar resources will also impact Earth's economy. The availability of rare earth elements and other materials from the Moon could reduce dependence on terrestrial mining and alleviate resource shortages. This shift could lead to changes in global supply chains, commodity markets, and resource management practices. In addition to mining, lunar tourism and commercial spaceflight will contribute to the growth of the space economy. As technology advances and costs decrease, space tourism will become more accessible to the public. Lunar tourism, including stays at lunar hotels and excursions to notable lunar landmarks, will offer unique experiences and drive economic activity. The development of spaceports and transportation infrastructure will support the growth of commercial spaceflight. The establishment of lunar launch sites and refueling stations will facilitate missions to other destinations in the solar system, creating new opportunities for exploration and resource utilization. Philosophical and ethical considerations. The Moon's exploration and colonization raise important philosophical and ethical considerations that extend beyond technical and scientific challenges. These considerations encompass issues of human identity, environmental stewardship, and the responsible use of space resources. The experience of living and working on the Moon will prompt reflections on human identity and the nature of existence. The isolation from Earth and the challenges of lunar life will lead to new insights into human psychology, resilience, and adaptation. Philosophical questions about the meaning of exploration, the purpose of human endeavor, and the significance of our place in the universe will be explored as we navigate the complexities of lunar habitation. Environmental stewardship will be a central ethical concern in lunar exploration. The potential for contamination and disruption of the Moon's environment must be carefully managed to preserve its scientific and cultural value. Protocols for planetary protection, waste management, and resource utilization will be essential for maintaining the integrity of the lunar environment. The responsible use of space resources will also be a key ethical consideration. Ensuring that the benefits of lunar exploration are shared equitably and that resource exploitation does not lead to conflicts or inequalities will be crucial for promoting social justice and global cooperation. Long-term vision and future prospects. As we look toward the future, the Moon will continue to play a central role in humanity's journey into space. The lessons learned from lunar exploration will inform our approach to missions to Mars, the outer planets, and beyond. The Moon's status as a hub for scientific research, technological innovation, and cultural expression will shape the trajectory of human exploration and development. The vision for a multiplanetary future will drive the continued advancement of space technologies and the expansion of human presence throughout the solar system. The development of sustainable habitats, advanced propulsion systems, and resource utilization techniques will be critical for achieving this vision. The exploration of the moon and other celestial bodies will inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM, and contribute to the growth of the space economy. Educational programs, outreach initiatives, and public engagement will foster a sense of curiosity and ambition, driving innovation and progress. Ultimately, the moon represents both a destination and a symbol of humanity's potential. It embodies our curiosity, resilience, and determination to explore the cosmos and expand our understanding of the universe. As we continue our journey into space, the moon will serve as a reminder of our achievements and a beacon of hope for the future. The exploration and development of the moon will shape the legacy of our era, defining our contributions to human knowledge, technology, and culture. It will inspire us to reach new frontiers, overcome challenges, and strive for a future where humanity can thrive among the stars. The moon, with its ancient allure and modern significance, will continue to guide us as we chart a course for the future and embrace the boundless possibilities of the cosmos. In this grand endeavor, we are not just exploring a distant world but embarking on a journey that will transform our understanding of ourselves and our place in the universe. The moon stands as a testament to our collective aspirations and a symbol of the boundless potential of human ingenuity. As we forge ahead, we carry with us the dreams and hopes of generations past and present, building a legacy of discovery and achievement that will inspire and guide us for generations to come. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video if you found this video helpful and subscribe to the channel for more such amazing videos.